Hello my dear students, welcome to this session. So last session we discussed super mesh analysis and we also discussed the minimum number of equations required in case of current source. So I dictated one point. What was the point actually I dictated? Let us recollect once again here. We put a note and written that in a given network, if it consists of L number of loops, what is L actually here? L itself stands for what? Minimum number of loops or fundamental loops. Okay, L number of loops, then how many equations you require? Minimum number of equations required is how much? L only. But this condition fails because if I draw the network once again here, what we have seen in the last session, there was a current source, right? There was a current source. Suppose if it is 10 ampere, let us say E1, R1, R2, all are known values here. If it is 10 amperes, if I assume the loop current something like this and the second loop current is taken like this, then what is the current flowing in this loop with this particular assumption or with this particular representation of the loop currents? It is definitely minus 10 amperes and I do not know what is the value of it. Let me call it I2. That means there are two fundamental loops, but one equation is enough to solve it. So that's why I told you that if there are L number of loops, minimum number of equations required is L. But this condition fails when there are some ideal voltage sources. In the case of ideal source problem or network, who will decide the minimum number of equations? Tell me. I just get the answer from you only. If I select I1, I2 like this, I got two equations, super mesh analysis. If I take I1, I2, where I1 is now defined easily without solving the network itself, okay, I got minus 10 amperes here. There is only one equation required. That means who is actually deciding the number of equations? In such cases, I told you that's why, in such cases, the selection of loop currents will decide the number of equations. Yes or no, all of you? Okay, the selection of loop currents will decide the number of equations. Okay, now here it is very clear. If I select the loop current, something like this, the justification for the statement given here, R1, R2, this is the current source, okay? E1, E2, let us say this is 10 amperes. Now, if I select, once again, current source only, E1, E2, R1, R2, this is 10 amperes, okay? If I select the loop currents, if I select the loop currents like this, okay, if I select the loop currents like this, I1 and I2, and I require the number of equations is 2. If I select the loop currents like this, this is minus 10 ampere, then the number of equations only 1. So what is the minimum number of equations required now? Is only 1 that you can achieve through this. If you go for super mesh analysis, how do you know it is forming a super mesh? Because there is a common element current source between two loops. Remember, between two loops or two meshes, if there is a current source, definitely it leads to the super mesh formation. Now, I'm not getting a super mesh here. Look at this. Who is the common element here? The common element is R1, not 10 amperes. Yes or no? Therefore, this is not forming a super mesh. If you go for super mesh, I'm getting two equations. If I'm not going for the super mesh and cleverly choosing the loop currents, then I'm getting only one equation. So minimum number of loops required for this particular problem is only 1. Understand all of you, okay? L number of loops, L number of equations required. That is a standard condition, no doubt in that. But that condition fails. That condition fails when there are ideal current sources. Understand all of you, okay? So please note down this. And also one more important point, you can understand that you can easily identify minimum number of loops here. Minimum number of loops or minimum number of equations in mesh analysis. In mesh analysis, I'm talking about, again, the story is different in the case of node analysis, okay? Minimum number of equations in mesh analysis is equal to, look at this. How many loops are there? 2 fundamental loops, okay? L loops. How many current sources are there? 1. 2 minus 1, one equation is enough to solve it. Understand? Okay. So 2 minus 1, okay, 2 minus 1, one equation is enough to solve it. Look at this. Now, that is why I derive one formula. We can generalize now, L minus number of ideal current sources. Ideal current sources. This is the formula for finding minimum number of equations in mesh analysis. Please note down that. It's very, very simple now. Okay, now you tell me, would you like to go for super mesh analysis in competitive exams? Never. If you go for super mesh, you are getting 2 equations. Understand? Okay, please note down that. Okay, so I gave the statement note in the given network, if there are L number of loops, then the minimum number of equations required is also L. But this condition fails when there are ideal current sources. In such cases, the number of equations are decided by the selection of loop currents. For that, justification is this, and final conclusion is that. Please note down this. This is a very, very important concept. Generally, all these things are not elaborated or explained in the textbooks, I'm telling you. Through experience, we are able to demonstrate, and in detailed version, we are explaining all these things. And these are all important in the competitive exams point of view. In the exam, he may be giving you a circuit and ask you to find minimums, okay? We will see. The first one is A. Find I1 and I2. B. Find VAB. C. V0. In exam you will get only one question. I am just trying to find several things here just for getting an experience in a single problem itself, okay? Find V0. D is asking what is the power of 6 volts and 3 volts. Please note down this question. Now let us try to apply only mesh analysis here as of now. After discussing node analysis, we will decide for a given network which method is the best method. In fact, you will be in a position to identify or judge properly, okay, which method is the best method for a given problem. That you can easily identify. Okay, so let's start doing this. Let us apply KVL. First we find I1, I2, then after that anything that you want we can easily find. Okay, KVL in loop 1. What is that? Minus 1 into I1 minus 1 into this one. First this one, right? I1 or I1 plus I2. What is the current flowing here? I1 is flowing. I2 is also flowing. Yes or no? Both are flowing in the same direction. So therefore, I1 plus I2 you are supposed to write. What about this? Minus 1 into, only I1 is passing through it. This element belongs to only first loop. This element belongs to only first loop according to the selection of loop currents. Yes or no? Minus 3, okay, plus 6 is equal to 0. Second equation, minus 1, I1 plus I2, minus 1 of I2, okay, then again minus 1 of I2. Two are there, both are correct in series, right? Then plus 6 is equal to 0. But I told you, you can apply inspection directly without wasting your valuable time writing the equations, taking them common, and again matrix form, then Cramer's rule. We can directly write the matrix form using inspection. What is actually inspection? Okay, what is inspection actually? We are explaining that inspection method based on our past experience. Say we have done some 100 problems. We observed certain points. Okay, we have done some, let's say 100 problems or 50 problems. Then we'll get some experience. Based on the experience, we frame the rules on our own. We framed our own rules. Okay, those rules I've explained you clearly. Inspection, 2 by 2 matrix because two variables are there. Number of resistors in the first loop, minus of 1 plus 1. Second loop, please, 1, 1, 1. 1 plus 1 plus 1. Common element, please. This is a common element. This is a common element, right? 1. How the loop currents are flowing in the common element? Same. Therefore, same sign, minus. Off diagonal symmetry, minus 1. Into I1, I2 is equal to energy sources in the first loop. There are two energy sources. Touching positive sign first. Look at this. It is touching positive sign first. Plus 3. Touching negative sign first. Minus 6. Now here, it is touching negative sign first. Minus 6. You understand, all of you? Okay. Then from this you can understand I1 is equal to delta 1 by delta. And I2 is equal to delta 2 by delta. That's it. So what is delta 1 actually here? Or what is delta here? Delta is, okay, minus 2, minus 1, minus 1, minus 3. Okay, 6 minus 1, it is 5. Delta 1 is equal to, okay, delta 1 is equal to, what is this actually here? Minus 3, right? So minus 3 minus 1, minus 1, minus 3. So what is this 3, 3? 9 minus 1. This is 8. Delta 2. What is delta 2? Minus 2 minus 1. You replace here. Okay. This is minus 3 minus 1. Oh, this is not, this is minus 6, right? Okay. This is minus 3 minus 6. This is minus 6 actually here. So 9 minus 6. This is 3. Okay. Now this is also 6 minus 6. Look at this, minus 3 minus 6. Now 12 minus 3. This is 9. Is it okay, all of you? Now, tell me what is I1. I1 is delta 1 by delta, that is 3 by 5. 0.6. Delta 2, 9 by 5. 1.5 amperes. That's it. 1.5 or 1.8. 5 1 ja, 5 8 ja. Right. 1.8 ampere. That's it. So I1 is 0.6 ampere. I2 is 1.8 ampere. After solving these equations, matrix form, Cramer's rule is very simple to apply. Okay. Now let us try to answer. The first question already you got now. You have answered it. 0.6 and 1.8 ampere. Now what is VAB? What is VAB? VAB is what actually here? VAB is the potential difference between 2 points. Okay, VAB is potential difference between 2 points. Potential difference between 2 points anywhere in the circuit can be determined using touching concept. Touching concept is nothing but KVL. We put a different name for KVL as touching concept. I told you already, just to speed up the calculation, I am calling it touching concept. Otherwise, it is just only KVL. That's it. Okay. So let us choose a path from A to B. All of you look at this. I'll give you sufficient time to note down the things. Okay. First, you look at this concept. Select a path between A to B. From A to B. How do you start from A and reach B? Like this you can go. Like this you can go. You can go like this also, doesn't matter. You can go like this also. Yes or no, all of you? But always choose the least, elements, number of elements should be least in that particular path. That path must be selected here. So if I select this, I got 2 elements. If I select this, I got 2 elements here. Yes or no? Okay. So let me select like this. If I select like this for VAB, for finding VAB here, this is already you got, right? Okay. Now for B, I'm just writing here VAB. For this, I'm selecting a path something like this. This is A, this is B. Make sure that the voltage across each element is known. When you apply touching concept, first you select the path and make sure that each element, across each element, the voltage is known. Make sure that each element, okay, is having certain amount of voltage. What is that voltage you need to find? Now, what is actually the current flowing here? I1 plus I2. Okay. What is the current flowing here? I2. What is the voltage across this element? I2 into 1. Yes or no? What is the voltage across this? I1 plus I2 into 1. Now, what is this value? 1.8 plus 0.6. That is 2.4. This is 2.4 volts. Okay. Now, what about this? Now, 1.8 volts. Yes or no? So, this is 1.8 volt. Sorry, 2.4 volts. 2.4 volts. And this is what? 1.8 volts. Now, tell me. VAB means, okay, you start from A and touching concept plus 2.4 plus 1.8. How much it is? 4.2 volts. You may have a doubt. Sir, if I choose this path, do I get the same answer? Yes, you get the same answer. Look at this once. What is the current flowing here? I2. So what is the voltage across it? I2 into 1, that is 1.8 volts. Yes or no? Okay. Now look at this. You're touching positive sign first, plus 6. You're touching negative sign first, minus 1.8. 6 minus 1.8 will also give you again 4.2 volts. Therefore, whichever the path you choose between A and B, okay, whichever the path you choose between A and B, you will get the same answer. Don't worry about that. Okay, but look for always the shortest path. That's better always. So you got this. Now, see, V0. What is V0 actually? The voltage across 1 ohm. Voltage across 1 ohm. You can see here, voltage across 1 ohm. Current through 1 ohm is how much actually here? How much current is passing through it? I1. I1 is how much current actually here? 0.6 amperes. Because of this current, you get the polarities plus minus and 0.6 into 1. But how you want the voltage minus plus? Because your desired voltage is having different polarities as compared to the actual polarities. Therefore, when there is a mismatch, I told you always to keep minus sign. Okay, that's it. Okay, first you note down this, then we will switch over to the power. We found so far these 3 and there is no space here, and after this we will go for the powers. First you please note down quickly. I'll give you the example we are seeing. Power. Let's find the power. Power of 6 volts. Power of 6 volts is 6 volts into current through 6 volt. But what is the current flowing here? I1. Yes or no? So therefore I can directly write here the current is I1. Therefore 6 into, what is I1 actually you had? What is I1? Okay, 0.6, right? So 0.6. Right. But look at this. current flowing through 6 volts, is it I1 or I1 plus I2? I think we have written wrong here, right? It's not I1. What is this? I1 plus I2. So therefore, what do you get actually here? I1 plus I2 is nothing but, okay, 0.6 plus 1.8, right? So 2.4, 6 into 2.4. Okay? 6 into 2.4. 14.4 watt. But what is this current doing actually here? I1 plus I2 is flowing like this. Whenever there is an active element, you must mention whether it is supplied power or absorbed power. Clearly you have to mention. That's always a good practice. Okay. So this is now supplied power or absorbed power. Current is leaving from positive. Supplied power. Now power of 3 volts is 3 into, now here the current flowing is only I1. Because this element belongs to only first loop. Therefore I1. Now 3 into 0.6, 1.8 watt. Now what is that current doing actually here? Plus minus. Okay. Downward. Therefore, entering into positive, I can say it is absorbed power. That's it. Okay. So please note it down. Meanwhile, I'll give one more problem. Example 2. Example 2. Please note down this quickly. Find So let us try to find all these things, okay? Using mesh analysis. Using mesh analysis, okay? We will discuss node analysis, then we will decide for a given problem which method is the best. That's a different discussion again, okay? First, let us try to experience how to apply the mesh analysis to any given network. Whether there are current sources or only voltage sources or current source voltage sources mix, doesn't matter. We must be in a position to solve it, okay? Okay. Now, we need to identify first of all, what are the minimum number of equations required to solve the network? Because when we analyze the network, we always should analyze with the minimum number of equations. Yes or no? Okay, otherwise the computation time will increase. Okay, a method is always said to be a good method. Okay, if that method takes less time. Therefore, let us now try to solve that problem using minimum number of equations. What is the formula for minimum number of equations in mesh analysis? I told you, okay, minimum number of equations is equal to number of fundamental loops minus number of ideal current sources. Now you got here 2 ideal current sources, and how many fundamental loops are there? 3 fundamental loops. So 3 minus 2, just one equation is enough to solve this problem using mesh analysis. But what should be the selection of loop currents so that you get only one equation? That is an important point. I know that I require only one equation, but to get that one equation, that single equation, okay, what must be the selection of loop current? That is very, very important here. Remember, always follow a simple logic that your selection of loop currents must be something like this. Each current source must experience one and only one loop current. You understand? Okay. If suppose the current source is experiencing more than one loop current, what will happen? The current source will become a common element for both the loops. Then it forms or it leads to the super mesh. And I'm sure that you're going to get a more number of equations. You are not going to get minimum number, you are going to get more number or maximum number of equations. So therefore, that logic let us implement. Each and every current source should experience one and only one loop current. This loop current, for example, say like this, it will be 9 amperes provided no other loop current is passing through it. Okay, now I can select like this or like this, doesn't matter. Okay, suppose if I select like this, okay, suppose if I select like this will be 3 ampere provided no other loop current is passing through it. You understand? Now you must select that third loop current, because 3 fundamental loops, 2 loop currents are defined because there are ideal current sources. Only one variable is required now. What is that one variable? It must be selected in such a way that that current is not passing through any of these current sources. Okay, so look at this now. I am selecting this loop. That's it. You understand now? Okay. Some people may say that, why can't I select current here? This is -3. No problem. Nothing wrong in that. You can choose like that also. That's what I'm saying. There is a flexibility in that. But what is the rule that you're supposed to follow? The rule is simple, that every current source must experience one and only one loop current. If more than one loop current is chosen, then it leads to the super mesh formation. Again, the number of equations will increase. You understand the logic? Now let us go for this. Now let us apply KVL in this loop. Okay. Now this element belongs to both second and third, right? Second and third. So what is the amount of current passing here? I plus 3. What is the current? What is the element belongs to here? This belongs to first loop, second loop and third loop. Remember. Okay. This element belongs to first, second, third. And this element belongs to only third loop. Yes or no, all of you? Okay. Well, so let us write the equation. Now I start from here. -1 into I plus 3 -1 into I plus 6 -1 into, I'm writing minus, that means what? This current is predominating. My assumption is what? This current is predominating. But already this current and this current both are in the same direction. Therefore I plus 3. But already one more current is coming in opposite direction. Therefore I plus 3 minus 9. I plus 3 minus 9. This is what the current actually we get. Now let us simplify it. Okay. So what do you get here? -1 into I plus 3 minus I. Yes or no? Okay. And minus I. So what do you get? Minus 3I. Now here minus into plus, that's -3. Okay. Plus 6. Now what is this actually? -6. But minus 6 minus of minus plus 6 actually here you have. Therefore 0. So what do you get here? Now I think you get 12 minus 3, 9. Okay. So minus 3I is equal to 12. That is minus 12. This is actually what is going to be here? 12. Okay. This is going to be 12. And minus 3 plus 12. This is 9. Then outside minus 9. And then you have I is equal to 9 by 3. That is 3 ampere. You understand all of you? Okay. So this is how you can, analyze the network. Very simple. In the explanation, it is taking too much time probably, but solving the network is very simple. When you have current sources, that is an advantage, not as a disadvantage in the mesh analysis. Because L is equal to, minimum number of equations is equal to L minus number of current sources. If number of current sources are increasing, the difference will decrease, the number of equations will decrease. You understand? Okay. Well, so I is equal to 3 ampere. Now let us try to find one after other. VAB. I think the simplification is correct, right? So please note down this first. Please note down this first quickly, and then we'll go for VAB and VAB. Okay, I think you got it. Now let's find VAB. For VAB, where is A actually here given? This is given A. This is given B. Please note down this. I think I have not shown initially, but please note down. This is X and this is Y. These are given actually in the network itself. Okay. So VAB. We would like to find VAB now. I told you already to choose a path from A to B. Okay. The first question here I am finding VAB. A to B, let us choose a path. Can I choose the path something like this? Yes, I can choose. I can go like this. I can go like this also. Doesn't matter. But why do we unnecessarily increase the complexity? Okay, length of that branch not required. Let us choose this one. What is actually the current flowing here? It is already in series with the current source. 9 amperes is flowing. So 9 into 1. This is 9 into 1. What is the current flowing here? I plus 3. Therefore, the direction of current here also, this is I plus 3. This is 9 amperes. This is I plus 3, right? So therefore, what is I plus 3 actually here? I is nothing but 3. 3 plus 3, 6 amperes. Therefore, 6 into 1, this is 6 volt, right? 6 into 1, 6 volt. Therefore, VAB will become plus 9 and plus 6. This is plus 15. Understand all of you? Okay. Now, VXY. 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 VXY means what? From X to Y, you choose a path. Let me choose directly here like this. This is 6 volt. Yes or no? This is 6 volt. What is actually the current flowing here? The current flowing here is what? Okay. I plus 3 minus 9. So what is I actually? 3. 3 plus 3 minus 9. So 3 plus 3 minus 9 is nothing but minus 3 amperes. Yes or no? 6 minus 9 minus 3 amperes. Okay. I is 3. 3 plus 3. 6. 6 minus 9 minus 3 amperes. What is the voltage? If you take the direction upward, what could be the polarities? Minus 3 into 1 volts. Yes or no? This is X, this is Y. Now let me start from X and reach Y. You are touching negative sign first. Minus of minus 3 plus 6 plus 9 volts. Okay? Like this. That's all. Okay? So you got VXY is equal to 9 volts. Now, C. Power. Power of, first let me go with 6 volt. What is the 6 volts power? It is equal to 6 into the current flowing through that. How much current is passing through it? Tell me. How much current is passing through it? I plus 3 minus 9. Yes or no? But what is the direction of that current? It is upward. Yes or no? That means applied power. Okay? That is 6 into 3 plus 3 minus 9. That means it is already 6. 6 minus 3 minus 3. 6 minus 9 minus 3. Minus 3 into 6 minus 18 watt supplied power. But plus 18 watt absorbed power. Okay. Now power of 3 amperes. What is power of 3 amperes? Power of 3 amperes, if you want to find, you must know the voltage. Yes or no? So first you note down this. I'll just explain you. There is a special, there is an interesting discussion how to find the power of a current source. Okay. So first you please complete up to this particular part. Then I will remove them and explain you in detail. Please do that first. This example is very important to understand. Remember, in network, so if you select the current direction upward, you got I plus 3 minus 9. If you select the downward, what will happen? 9 minus I minus 3 you get. In that context, what you get? Plus 3 amperes, then plus 3 volts. The polarities will become plus minus. Again, you get the same thing, minus of minus plus only. So finally, you get the same answer. Don't worry about that. Okay. What is the current you choose? You choose that whatever you want to do, you do it. But you place the polarities according to the selection of the current that you have chosen. Okay. Now, let's go with the power calculations of the current sources. Always power of current source is something special in the networks. I mean, you require a systematic procedure, otherwise you will be definitely in trouble. Okay. Okay. Now you tell me, to find the power, what is actually power, voltage and current product? In case of voltage source, we know the voltage, we need to find the current. So finding the current in the voltage source is very easy task in fact. And I told you to find the current, you must check whether that path is having any resistor or not. If there is a resistor, you can definitely find what is the current flowing to the resistor, then automatically you know what is the current flowing to the voltage source. If there is no resistor, then apply KCL, you can get it automatically. Okay. So here this is very simple procedure, but let's go with the current source here. Current source, that is power of 3 amperes. What you do is, in case of current source, first you assume there is some voltage across current source, Vx, let us say. Okay, first you choose some voltage Vx across the current source. Okay, sir, how should I place the polarities, plus minus or minus plus? Please go for the random selection. Okay, I'm not worrying about that. If my assumption is correct, I may get positive value. If my assumption is wrong, I may get negative value. Okay, okay, if I get negative value, it means that if I choose chosen minus plus, I would have got positive value. That's why don't worry about that. Just choose randomly. And now from plus to minus, you select a path. Any path, plus to minus, like this you can go, like this you can go, yes or no? You have different paths, but I think this is the best path because already these two are connected in parallel. So therefore, what are the voltages appearing across this? You can directly find the voltage across this. Therefore, what is the voltage actually here? I, okay, is the current. Then I into 1, okay. Then what is this value? I value, how much you got? 3. So 3 into 1, 3 volts you got. Understand all of you? Okay. So I have chosen that path is very simple. Okay. I got now current source and resistor both are parallel across each other. I got 3 volts. Therefore, so this is very simple to find. But the other current source, let's see. The voltage across this one, this is actually 3 ampere. The voltage across how much here? Vx is equal to 3 volt. Therefore, the power of 3 ampere is, okay, 3 into 3, 9 watt. So what is this current doing? Leaving from negative, nothing but entering into positive, therefore absorbed power. Understand all of you? Okay. Now, power of, what is that? 9 ampere. What is power of 9 ampere? Again, select some voltage across it. Vy. Polarities, random please. Don't get confused. Polarities, random. That's it. Okay. Let's see what will happen at the end of finding the value. Choose a path from plus to minus. I can choose the path like this. I can choose the path like this. Potential difference between 2 points anywhere in the circuit. What is the procedure? KVL or else touching concept. Okay. Now let us use the touching concept by choosing a path. Like this. I am choosing the path here. This is plus minus Vy. This is 1 ohm. This is 1 ohm. What is this? Actually 6 volt. You already know how much voltage is there. 9 volts. Yes or no? You already know how much voltage is there. Just now we found actually that voltage also. So what is the voltage here also? Plus minus. 9 minus I minus 3. That is 3 volts. Now tell me what is Vy? Vy is equal to plus 9 plus 3 and plus 6. How much it is? 18 volts. Now what is the power? You got positive value. It means that your assumption is correct. Okay. It means that your assumption is correct. Even if you get minus plus, then what you get? Minus 18. Plus minus 18 is same as minus plus minus 18. Both are same. Yes or no? That is why do not worry about the polarities. Choose randomly. Let's see what will happen. But don't choose the polarity just based on the direction of current. Don't think that like that because there is no relation between this current direction and these polarities. It is a multi-source network. Anything may happen. Okay. Now power of this 9 amperes is equal to Vy into what? This 9. This 18 into 9. 162 watt. And look at that current source actually here. This is plus, this is minus. Yes or no? This is plus, this is minus. Current is leaving from positive, therefore it is supplied power. So this is a way how to find. This is a way how to find the power of the voltage source, the current source.